You know that feeling? You update something on your computer hoping for, I don't know, improvements, maybe things run a bit smoother,
Yeah.
and then bam, suddenly things just look off. Your screen starts doing weird stuff, visual glitches, flickering maybe, things get all garbled up.
Oh, yeah. Makes you seriously wonder if your graphics card just decided to pack it in.
Totally. And look, for a bunch of people using Firefox on Windows recently, like right after they updated to version 139, this wasn't just some minor visual quirk.
No, not at all. They were seeing really severe graphics artifacting. It was making the browser experience incredibly frustrating, sometimes, well, almost unusable.
It sounds like it was really jarring.
Right.
So, okay, today we're doing a deep dive into exactly that. We want to get into why some Firefox users on Windows hit those really bad visual problems.
Right, and what Windows tech was involved, and maybe what this whole thing tells us about, the bigger picture in the graphics world today.
Before we jump right in, though, just want to mention that this deep dive is brought to you by Stonefly. They're leaders in enterprise storage, backup, and disaster recovery.
Yep, really focused on secure solutions, things like ransomware-proof, air-gapped, and immutable storage.
So if secure storage is on your mind, you can reach out to them at sales@stonefly.com to set up a demo. Okay, back to the Firefox issue.
Right, so our mission here is to unpack the technical bits, figure out what caused this sort of perfect storm bug, and see what we can learn about how complex modern computing really is.
Okay, let's start with what people were actually seeing. Because it wasn't subtle, was it?
Oh, definitely not subtle. People described like severe visual distortions. We're talking crazy artifacting, videos flickering uncontrollably, bits of web pages looking totally garbled.
UI elements jumping around.
Yeah, UI elements spazzing out, basically. The common theme was the visual output of the browser was just fundamentally broken for them.
Wow. So not just annoying, it actually stopped people from using Firefox properly.
Absolutely, even for basic stuff. And like you said before, it definitely made a lot of users think their graphics card or maybe their monitor was suddenly dying.
And this wasn't hitting everybody, right? There was a kind of profile for the users who saw the worst of it.
Exactly. The reports quickly zeroed in on Windows users, specifically Windows users with NVIDIA graphics cards,
Okay.
and even more specifically, users running multiple monitors. But the real kicker, the critical ingredient, seemed to be having monitors with different refresh rates connected to that NVIDIA card.
Ah, okay. So like you've got your fancy high refresh rate monitor for gaming, maybe 144 hertz, 165 hertz, something like that,
Right.
paired with a standard secondary monitor just chugging along at 60 hertz.
Precisely. That specific setup, NVIDIA card, Windows, mixed refresh rates, that seemed to be the combination where this bug really manifested itself most severely.
Okay. So to get why that specific setup was the problem, we need to dig into how Windows actually, draws stuff on the screen. There's a key Windows component involved here, right? Direct composition.
That's it. Direct composition, or decomp, as it's often called. It's a core Windows system, and its whole purpose is high-performance visual composition.
Composition, meaning putting things together.
Exactly. Think of it like this. An application, like Firefox, draws its content images, rendered graphics, UI bits. It draws these, usually as bitmaps. Then it hands these pieces over to decomp.
Okay.
And decomp takes all those different pieces and efficiently combines them, applies effects like transparency or animations, handles scaling and rotation, and basically builds the final image that you actually see displayed. It's designed to do this really efficiently using the graphics hardware.
So it's like the final assembly stage for the visuals?
Pretty much.
Yeah.
Especially for smooth animations and transitions. It works with bitmap content that the application provides. It doesn't deal with raw text or vectors itself.
Yeah.
It gets the pictures and arranges them.
And it organizes these pictures using visuals and a visual tree. That sounds technical.
It is a bit, but the concept is straightforward. Visuals are just the building blocks. The images are containers. They're arranged in a hierarchy, a tree, kind of like folders and files. Properties set on a parent visual, like position or opacity, affect the child visuals inside it. Decomp takes this whole tree structure and renders it out.
Got it. So Firefox uses its rendering engine, WebRender, to draw the web page using the GPU.
Right.
And then on Windows, it often hands those drawn pieces over to Direct Composition to put it all together on the screen.
That's the flow, yes.
Okay, that makes sense. So where did Firefox 139 stumble in that process?
Well, the heart of the issue was linked to a specific setting inside Firefox, controlling how it used direct composition on Windows. There's this preference, gfx.webrender.decomp on pwin.enabled.
Okay.
In Firefox 139, for these users with the NVIDIA mixed refresh setups, That setting got flipped on by default.
And it wasn't on before for them.
Correct. In earlier versions, Firefox had what they called a blocklist. It was basically a safety check. It specifically stopped Firefox from using a certain decomp behavior or pathway on those known problematic setups, the NVIDIA mixed refresh ones.
Because they knew it could cause issues.
Apparently so. But in version 139, for reasons we might not fully know, that blocklist was removed.
Okay. So they removed the safety rail. Firefox started using this decomp path again. And that's when things went haywire visually for those users.
That's exactly it. The thinking is that Mozilla's specific way of feeding content into direct composition. The tech details mention using surfaces rather than swapchains for a lot of the web content.
Surfaces versus swapchains. Briefly, what's the difference there?
Okay, think of graphics buffers. A swapchain is often used in games. You draw to one buffer while another is displayed, then you swap them, usually sync to the monitor refresh for smoothness. Surfaces, in this decomp context, might be handled a bit differently, maybe for more granular updates or different kinds of content layering. The crucial part is how Firefox was managing and updating these surfaces and feeding them to decomp.
Right.
That specific method, when the blocklist was removed, seems to have hit a sensitive spot, maybe an underlying bug, within the NVIDIA graphics driver itself, but only in that mixed refresh rate environment.
Gotcha. So it wasn't just Firefox, and it wasn't just the driver. It was the specific interaction between Firefox's decomp usage and the driver on that specific hardware setup.
That seems to be the consensus, yeah. And the visual chaos, the artifacting and flickering, that was the direct result of this clash. Imagine you've got content updating at one rate, say 60 frames per second video on your 60 hertz monitor, but you're also interacting with stuff on your high refresh monitor. Because of the driver issue triggered by Firefox's decomp use, pieces of the image data meant for one area could sort of bleed or get corrupted into other parts of the browser window during the composition process.
Which would explain the random flashing and weird visual junk appearing everywhere the page needed to repaint.
Exactly. And interestingly, some reports noted that content running at 30 FPS often didn't show the issue as badly.
Why is that?
Probably because 30 FPS divides more cleanly into both 60 Hz and typical high refresh rates like 120 Hz or 180 Hz. The timing mismatch wasn't as severe.
This is making sense, but it also feels like, well, this Firefox thing didn't happen in a total vacuum, right? It feels like there's been more general chatter about graphics driver instability lately, especially around NVIDIA.
You are absolutely right. It's important context. This Firefox issue landed during a time when we've seen increased reports about NVIDIA driver stability, particularly with some of the newer driver branches, like the 572 series and onwards.
And it's not just one type of card.
No, the reports seem to span different GPU generations.
Yeah.
The 30 series, the 40 series, even some early reports mentioning the new 50 series cards.
And the problems reported are quite varied too, aren't they? We've heard about everything from minor glitches to full system crashes, reboots, weird screen distortions, often linked to gaming features like G-Sync or frame generation or DLSS.
Yes, the scope seems quite broad. And some of the digging into these other driver issues has turned up some really bizarre factors.
Like what?
Like research suggesting that even which physical display port or HDMI port you plugged your monitor into on the graphics card could make a difference.
Wait, seriously, the actual physical port?
Yeah. And also how Windows itself identified the monitors, like which one it decided was monitor 1 versus monitor 2.
Yeah.
Apparently, in some cases, changing the port or how Windows numbered the displays could influence whether these instability issues popped up.
That is incredibly strange. It adds a whole other layer of physical hardware weirdness to the mix.
It really does.
Yeah.
It highlights just how many variables are at play. So yeah, looking at it with that background, the Firefox bug seems less like a totally isolated incident.
Right. It's more like a very specific, very visible symptom of these incredibly complex interactions. You've got the browser's rendering engine, the OS composition layer, the graphics driver, the specific hardware setup.
All interacting. And when one piece changes, like Firefox removing that block list, it can expose to sensitivity or instability in another layer, like the driver, but only under very specific conditions, like the mixed refresh rates, especially if that driver layer is already maybe a bit fragile, as suggested by those broader reports.
Okay, so for the poor folks stuck with a glitchy, unusable Firefox after that 139 update, what was the immediate fix? How did they get things working again?
The main workaround that spread pretty quickly and was confirmed by Mozilla involved diving into Firefox's advanced settings.
Ah, the about.config page?
That's the one. You type about.config in the address bar. Promise you'll be careful.
Yeah, yeah.
And then you search for that preference we mentioned, gfx.webrender.decomp.neop-win.enabled.
And just flip it back to false.
Exactly. Set it to false. That effectively told Firefox not to use that specific direct composition pathway that was triggering the problem on those systems. It basically put things back, behavior-wise, to how they were before the blocklist got removed.
Did disabling hardware acceleration altogether also work? I thought I saw some mention of that.
Some users reported that helped too, yes. But disabling all hardware acceleration is a much bigger hammer. It can impact performance across the board. Flipping that specific decomp1 flag was the more targeted fix just for this particular issue.
Right, makes sense. And props to Mozilla, they didn't leave people hanging with just the workaround for long, did they?
No. They were impressively fast. They identified the root cause, confirming it was tied to removing that block list very quickly.
And pushed out an update.
Yep. They released Firefox version 139.0.1, a specific point release just to fix this. And the fix was essentially, well, putting that block list logic back in.
So preventing Firefox from using that troublesome decomp behavior on those specific NVIDIA Windows mixed refresh setups again?
Precisely. Problem solved, at least for this specific manifestation.
And I bet the community feedback was crucial there. People reporting the bugs, sharing their hardware details.
Oh, absolutely. You see this all the time with complex software. The developers rely heavily on users reporting issues, providing diagnostic info, testing potential fixes. That transparency and collaboration is key to getting things sorted out quickly when these weird edge cases pop up.
So let's zoom out a bit. Thinking about this whole incident, what does it really tell us about, software and hardware today?
I think it's a really stark reminder of just how incredibly complex it is to build something like a modern web browser. I mean, just think about the sheer variety of systems it has to run on.
Different OS versions, different graphics cards, AMD, NVIDIA, Intel, countless driver versions for each.
Different monitor setups, resolutions, refresh rates, peripherals. The combination matrix is just mind-boggling. Getting it to work reliably everywhere is a monumental task.
Yeah, and you can definitely understand why users get frustrated. You update your browser, something you use every single day, for basic things like scrolling a web page or watching a quick video, and suddenly it's broken. Especially if your setup, like having two monitors, feels pretty common these days.
Absolutely. There's always that tension, isn't there? We want the latest stuff, new features, better performance, critical security patches, which means regular updates. But we also just need our tools to work reliably. Stability is paramount.
But like you said, there's a positive side too. The quick response, Mozilla being open about the issue, the community pitching in. It shows that even with this complexity, these problems can be tackled effectively when people work together.
Definitely. It's not a perfect system, but that feedback loop is vital.
So wrapping this up then, the Firefox 139 graphics mess, it was really a perfect storm, wasn't it? A specific change in Firefox's code.
Interacting with a specific Windows component, direct composition,
Running on a specific graphics driver from NVIDIA.
which seemed to have an underlying sensitivity, possibly related to broader stability issues.
And all triggered under a specific hardware configuration. Mixed refresh rate monitors.
Exactly. It shows just how interconnected and, frankly, sometimes fragile these layers are.
It really does make you stop and think, doesn't it? How much we rely on this incredibly intricate stack of software and hardware just working together seamlessly for our everyday digital experience. Scrolling a web page, watching a video seems so simple, but behind the scenes, it's this incredibly complex, delicate technical ballet. And as we thought here, it just takes one little change, one slight misstep in that choreography.
And a whole performance can fall apart visually.
Right.
A delicate dance indeed.
Well, that brings us to the end of this deep dive. A big thanks again to our sponsor, Stonefly leaders in enterprise storage, backup, and disaster recovery, AI storage, and cloud solutions.
Remember, if you need secure, ransomware-proof storage, check out their air-gapped and immutable options.
You can contact them at sales@stonefly.com to schedule a demo. Thanks for joining us.